Welcome everyone. Thank you for taking the time to join for this webinar session. My name is Dennis and I will moderate today's webinar with the subject We solved the Enig corrosion issue. First and foremost, I would like to introduce to you Dr. Britta Schaffsteller, who is our speaker and subject expert. Britta joined the company back in 2004 as R&D chemist in the field of final finishing for electronics application, until she was appointed in her current role as a global product manager selective finishing for our surface treatment technology division. She's a true expert in her field and we are excited to have her here with us today. A couple of words about the webinar. The webinar will be divided into two parts, 40 minutes presentation and 15 minutes Q&A session. I encourage you to raise questions from the beginning of Britta's presentation and therefore to use the Q&A function, which you can find on the top right corner of your screen. Your questions will be visible only to me and Britta, therefore do not hesitate to ask any related to the topic question. We will try to cover as many questions as possible during the planned Q&A session at the end of the presentation. If the time allows, we will answer all questions right away. Also, Britta will be available after the webinar to reach out to you via email. Last but not least, if you face any technical issues, please make sure to enter the webinar via the latest versions of Chrome or Firefox browsers. Now let me hand over to Britta. Please enjoy the session.
Yes, thank you, Dennis, for the kind introduction, and welcome everybody to join this webinar now in here. So I'm going to talk about our latest gold bars development, the Aurotech G-Bond 2, which actually helps us to solve the Enig corrosion issue. I'm going to start with a brief background introduction why we looked into a development of a new gold for Enig and why corrosion might be a critical topic. And with that, I will go also through a brief history of the different gold electrolytes which are there, which are available in the market and still being processed in the market, and what are the differences in terms of the reaction mechanism and also the properties and the corrosion properties, the Enig corrosion properties they have. Later on, I will go in more detail and introduce to you the Aurotech G-Bond 2, which is now the latest gold bars that we have available, and will end with a brief summary to wrap up the seminar. So let me start with a background and the introduction. When we talk about ENIG, it's the abbreviation for electroless nickel immersion gold. So we are talking about an immersion gold process where we deposit gold by dissolving nickel. It's a displacement reaction, and actually the electrons are only provided by the dissolution of nickel. And in the standard immersion gold bases, this is the main reaction, and we really need to dissolve the nickel to be able to deposit the gold. And there were already approaches earlier to add some additives to the solution to help or to support the reaction, to minimize the dissolution of nickel, and maybe even to provide some additives which may act as, or which have some reducing capabilities, and with that can reduce the nickel dissolution to a minimum. With the latest state of the art mixed reaction immersion type of gold, we have actually a combination. So we have additives inside which provide already some reducing activities or which some reducing properties, and with that can provide some additional electrons and reduce the nickel attack. Typically, the areas which are attacked most are the areas here in between the nickel nodules, because there we have a lower phosphorus content compared to the bulk nickel layer. And so these are the weakest areas, and this is typically where the corrosion attack takes part. And the purpose of the additives is actually to level the corrosion attack and to distribute the corrosion attack more evenly over the whole nickel layer. By applying additional additives to the gold solution, it also helps to improve the thickness distribution. So the plating reaction is less sensitive to, for example, the pad size. And there are actually different types of additives which can be added to the gold bars, and they have, let's say, different, or they will lead to different ratios of the immersion reaction and the reductive reaction in the gold. So the stronger the reducing agent is, the more of the autocatalytic reaction you will have in the bars. So with the latest mixed reaction immersion type of gold, this typically works like that we start with an immersion reaction where we really, the electrons are provided by dissolving the nickel, and then as soon as the gold there are some gold seedings deposited, these gold seedings act as a catalytic surface for the reducing agent which are in this solution. And then the reaction shifts to the autocatalytic reaction, and the reducing agents take over, which really helps to reduce the immersion attack to an absolute minimum. So this is how also the Aurotech G-Bond 2 works. And if we look into the different gold bases that we have in the market, you can actually distinguish three different kinds of, or three different generations of gold. In the very beginning, when ENIG was developed, we started with a first generation gold where the full reaction was immersion type, all electrons provided by the dissolution of nickel. And this is, for example, the Aurotech SF+, which is already in the market for basically for decades, and works as a reliable gold base to provide a reliable ENIG finish. The corrosion type, if you see corrosion, then typically looks like you can see here, this type of spikes or spreaders, which you will find preferably at the entrances of the PTHs at the let's say knees, where you have the highest agitation or the highest flow of the solution going through the PTHs. So these are the areas where you typically find corrosion. And then there were already the work done to reduce corrosion, and we came up with a second generation base, which is a mixed reaction gold, where we have some additives inside which support the reaction and have a certain portion of autocatalytic reaction. We have here two gold bases, the Aurotech DC, Aurotech DC-CH, and they are both, compared to the first generation bases, they are corrosion optimized, so they show far less corrosion, and they already provide an improved thickness distribution. Compared to Aurotech DC, the Aurotech DC-CH also provides extended lifetime, so can be processed longer without any issues. If you look for corrosion with these bases, you might find some single spots, and this is how this typically looks like. You really have to search for, but if you find some spots, it will be single events, and they typically have this bite shape and do not penetrate the nickel layer more than 20 to 40%. So this is the maximum actually you would expect for this type of gold bars. And now what we talk about now is the third generation of gold bars, where we have a higher autocatalytic portion. So we have different reducing agents here inside, which take over the major part of the deposit reaction. And we have already in the market since a couple of years the Aurotech G-Bond for ENEPIG plating, and which provides already an corrosion-free finish for ENEPIG. Compared to the second generation gold bases, we have a further improved thickness distribution. Because of the autocatalytic portion of the reaction, we are also able to deposit high thicknesses. And to process or to operate this base, we also offer an automatic dosing system, which ensures to have a constant replenishment for the whole operating time. Based on this Aurotech G-Bond that we have in the market and which is already in production, we now develop the Aurotech G-Bond 2 and the one which I want to talk about now today. So the major difference is that this base is now also applicable for ENIG and ENEPIG, and but comes with the same benefits that we have already for the Aurotech G-Bond. So it can deposit corrosion-free so that we do not see any corrosion in the cross-sections. We have the further improved thickness distribution. We are able to plate high thickness on ENEPIG or ENIG, and we can use the same dosing system that we already have in place for the Aurotech G-Bond. And if you look into the cross-sections of this base, you will really see that this cross-section is defect-free. But more will come later on that. So let's go in more detail for the Aurotech G-Bond 2. The driving force or the motivation for the development was for sure also the IPC 4552, which describes the ENIG finish. And in the version A, which is currently valid, there are already some descriptions how corrosion shall be rated to see or to judge if a panel or a finish may be critical in the assembly or not. And the version B, which is currently being negotiated and let's say under preparation and will hopefully be released soon, will then further describe and define when you have to look for a corrosion, how many areas you have to inspect, and really to distinguish which type of corrosion will be critical and which can be pass-fail criteria for a PCB to decide if it can be accepted or not. And so the main motivation for the whole base development was for sure to fulfill the requirements of the 4552A, but also to fulfill the future requirements of the versions to come. And we actually looked into the experience that we have in our bases which are there in the market, so the Aurotech DC, DCCH, and the Aurotech G-Bond, and did some feasibility studies to see if or how we could further improve and find a way to apply the third generation gold base also for ENIG. And actually that worked out very well, so that we found very good solutions to provide for the autocatalytic reaction also for ENIG. So the base that we have, the status, actually the base is ready for sampling. So we have the products there, and it's applicable for sampling in the tech centers in Asia, in China, or here in Berlin, in Europe. And it is also able for sampling in the customer side in US, California. So the features of the base that we have now is the process operates with a low gold content of 0.5 gram per liter with a high bar stability and no tendency for any plate out or precipitation or dust formation. The ENIG corrosion level, and I will describe later on what I mean with that, we can see level 0 or 1. And with that, we can create an overall rating of 0. So we really don't see any corrosion in the cross sections. With that, the base comes with an excellent thickness distribution of below 5% of the COV. And this also helps to, let's say, save money in the process, because you can really have a low range in the variation of the gold, and you have low drag out losses because you run with a low gold content. The appearance of the layer is fine crystalline and yellow, and there is no tendency for any dark or reddish discoloration in the layer. And the process, as I mentioned earlier, also comes with a dosing system, which helps you to have a constant replenishment without any extra effort. As I said, products are introduced and the bus is ready for sampling in tech centers or at a customer. So for the details for the gold bars itself, set point of the gold is 0.5 gram per liter. Operating range is 0.3 to 0.7, which is already quite low limit. So this is what we set currently as the operating range, because the lower you go with the gold content, the more difficult it also will be to really keep the gold content controlled. Even though we do not really see issues if you would even go further. The temperature we work at is a typical operating temperature of gold bars at 81 degrees. And the plating rate for ENIG is 6 to 8 nanometer per minute, and for ENEPIG 5 to 6 nanometer per minute. The pH is pretty mild at the pH of 8. This is a set point with an operating range of 7.8 to 8.2. And the lifetime is 2 to 4 MTO, comparable to the existing process as we actually run. So we are currently confirming the lifetime, and as we actually run with a lower gold content compared to the existing G-Bond process, which operates as 0.8, we even expect that we are able to go higher to 6 MTO here. What I would like to highlight is that the process can be combined with all ENIG and ENEPIG processes, so with all different mid-phosphorus electroless nickel bases as well as high phosphorus, and also with the pure palladium as well as the palladium phosphorus deposits. About the thickness distribution, for example, we did 2 tests. So on this page, you see that we have tested or measured thickness on different pet sizes. So on a panel where we have, you see the pet size areas over here, and the 6 pets were measured, and on these 6 different pet sizes from 0.2 to 49 square millimeter, you can find a CV of below 3%, which actually is here the 2.5%, which is pretty good. And what is also of interest is the thickness distribution on the panel, on the overall panel, on the same pet size. So here measured on 20 IPC pets distributed over the full panel, and even here we can have a low CV of below 5% when measuring overall the full panel size. So this, what I would like to introduce here is the so-called dosing master. So this is the automated dosing tool that we offer with this gold bars. And this actually consists of several pumps and control unit where you actually program the dosing frequency and volumes that you need for the bars, and then the dosing starts automatically as soon as the bars reach a certain temperature, so that you can be sure as soon as the bars is on temperature, it will be replenished automatically, and you can be sure that with that the bars can be kept stable and will have no tendency for any precipitation or played out. And if we look into the soldering and bonding performance, let's start with a the simple solder spread test. The test is really pretty simple. So you start with a panel where you print some solder paste, then the paste is reflowed, and what you measure is actually the wetting or the spreading of the solder on the surface, and you measure the wetting angle, and the lower the wetting angle is, the better the solder spreading on the surface is. And this is what we did here. And this is the overall results. There are several conditions which were tested here, because this was the result of a working window DOE that we did, where we varied the complexing agents in the bars, the pH, the gold bars temperature, and the gold content. And so for all the different conditions, what we can see is that we are in as received conditions far below the upper limit of 20 degrees, and in after 2 times reflow, also for all the conditions, we are below the upper limit that we want to receive. So for the solder spread tests, we also did for ENIPIG, and here the distribution of the results is even more, let's say, more homogeneous, or evenly. There is less impact of the different factors of the gold bar variation, but again, all results are far below the limits for the pass-fail criteria, and all conditions for the whole working window were passed. And then to look into the solder joint reliability, we did cold ball pull tests for all the test conditions for the whole working window DOE. And for this test, going back to this one, 30 solder balls were applied. The ball diameter of the solder balls was 450 micrometer. The solder resist opening was 380 micrometer. And then the balls were attached and pulled off. And what we see for ENIG is that the pull strength is also consistent for the full working window that was tested. On the left side, the as received results. On the right side, the results after 2 times reflow aging. And again, we see that they are basically all passed for ENIG. And if we move to the next slide, the ENEPIG results are again very consistent. So there are no conditions which are really far out and which are really, let's say, failed. For ball shear tests, which was done as well, again with 30 balls per conditions or the same size. Here the ENIG results, what we can see is that we really have only fracture modes of 2, so they are all excellent. And again, the shear strength is same for all the conditions. There are no big significant variations. And the same is true for ENIPIG. Again, the bath works over the full working window, and again, we only have a mode 2 fracture modes for any condition that was tested. Let's look into the corrosion evaluation. So what you see here is just some exemplary SEM images, which is actually, I would say, easy to show, because you could always pick some nice images for any gold bath that you want to investigate. But this is just some exemplary pictures to show. And if we look here, if we strip the gold off, you also see that the nickel layer is defect-free and you don't see any obvious corrosive attack. But to really, let's say, study the corrosion attack a bit more in depth, we also did kind of statistical evaluation, which basically works like that we do a counting of the corrosion events. What we typically do is that if we check one condition, we investigate minimum 6 to 8 PTHs per condition. And for these PTHs, we check again different locations per PTH. So we typically investigate minimum 7 locations per PTH, which are the 4 corners of the PTH entrance and the PTH rings. And why the PTHs? Because they are typically the location on the PCB where you find the corrosion first, because of the solution flow there. So what we look at, if we have one panel which we want to investigate for corrosion, we cut out and prepare a cross-section of 8 PTHs and then look 7 locations per PTH. And what we do then is that we count how many corrosion events we see over certain depths. So we categorize somehow into certain classes, like we have corrosion events with 0 to 20% of depths. We have a corrosion event of 20 to 40% of depths. We have corrosion events of 40 to 100% of depths, and we may even see some surface corrosion. And then we categorize and say, okay, if we don't see any corrosion, this we call a level 0. If we see few events which are not deeper than 20%, then this we count a level 1. If we see any surface corrosion, or if we see any really severe corrosion which is deeper than 40%, and we see numerous of those, then this is a level 3, and everything in between is level 2. So what we are looking at is really, of course, to have a level 0 or 1 preferably. And what you see here on this slide is a comparison of the Aurotech DC CH and the G-Bond 2, and so the second and the third generation gold. And if you now look down here in the overall summary of the level, you see that for G-Bond 2 we really have only level 0 for all the PTHs which were investigated. And for this, from this level, we create a kind of mean value, and this means the rating. The rating is basically, if we have no corrosion at all, then we have a rating of 0. And if a corrosion rating of 1 would mean if we see or most of the investigated locations, more than 60% have a level of 0 or 1. So a rating of 1 still would be very good result. So this is what we see for the Aurotech DCCH, for example. There we see some single events and which create this rating of 1. But for Aurotech G-Bond 2, there definitely we have no corrosion at all. So we really have a full rating of 0. To get some more data, we investigated some more panels here. So here we compare our standard test boards, the same test board design, but this was prepared at a customer site in the US. And the third one is a condition with a very high thickness of 13 microns, so 0.3 micrometer. And again, what we see here, if we go down here, we have a rating of 0 for all the conditions. We have a level of 0 for all the conditions for all the PTHs which were checked on these different PCBs. So to show some more data, we did the same investigations of actually 10 PTHs per condition, also for the working window test. So for here we tested 11 different conditions, 10 PTHs per condition, and per PTH 7 locations. So overall 770 locations were investigated for corrosion. And in this working window you see, maybe you don't see because it's very small, it's just to bring the whole table in here. But what you see is that you basically have a full rating of 0 for all the conditions. There are, if you look very closely, there are in fact 3 single locations where you find one small corrosion spot. But what I have to say is that these are the conditions of the working window where the bars is far out of range. So where the complexing agents, for example, are about just half of the target concentration. So basically this was the working window to see really, okay, where can we operate the bars? And if we now tighten the spec ranges which are in the TDS, we can be really sure that the process really works without any corrosion. So this is the results for ENIG, and for ENEPIG is actually similar. So you have again the 770 locations which are investigated, and 99.5% are total corrosion free. So you have, even in this working window where we are outside of the target, far outside of the target values, the bars performs well. Some more exemplary pictures to show how the layer then looks like. So what we typically apply also is a protection layer of the nickel, because this helps a lot to detect surface corrosion. Because this is just to, if you prepare the cross section, there is a risk that during the polishing and the grinding, you kind of peel off the gold layer from the nickel if you don't have any protection layer applied. And so therefore, if we really want to look for critical corrosion like the surface corrosion, it's better to apply the protection layer, because it really ensures that you will detect any corrosion which is there. So this is how we looked at it, and this is what we see. There is really no corrosion to detect, and this is the sample with a thick gold, so with a 13 microinch of gold, or 0.3 micrometer. So it brings me to the summary for this bars. So the major benefits of this bars is for sure that we can achieve a consistent ENIG corrosion performance with a rating of 0, so no detectable corrosion. The bars operates with a gold content of 0.5 gram per liter, which helps you to reduce the process cost, because you can reduce the drag-out losses of the precious metal. And at the same time, it also works with a very good thickness distribution of below 5%, which helps you to really run with a low thickness window to be plated. The bars has a high bar stability and a long lifetime, and comes with the automated dosing system, which helps you to operate the bars and to be sure that the replenishment is consistent and reliably. For the plating formulation, we have patents in place. And so this final slide is really to wrap up the major benefits of the bars: that we have no corrosion, and that we can fulfill the IPC 4552 in the current and in the future versions, that we can operate with a low gold content to save some money and to bring the bars with a high bar stability, and also can provide the equipment to, let's say, support the process and to ease the maintenance for this process. And with that, I thank you, and thank you for your attention, and looking forward to the questions.
Thank you a lot, Britta. Was very interesting to follow. So it's time to proceed with our Q&A session. We received many questions, so I would like to remind you that we will cover as many questions as possible during our session, and all the rest will be answered by Britta after the webinar via email. So let's start. Our first question is, what is the market share of different cold bus generations in the market?
So that's interesting, because we have the first generation, which is already in the market for more than 10, 15 years. And still this bus, at least from our process still has 60% of the market share in our customers. And so even this bus, which shows some corrosion, is processing reliably ENIG layers in the majority of the customer sites. For the second generation gold bars, it's basically now the 30 to 40%, and with the third generation, this is really a new process which is now coming up and which is just in a few lines so far.
Okay, thank you. So, question about gold bus stability. Is the gold bus stable over bus life?
Yes, it is. So what we really don't see is any indication for precipitation, for any reddish dust formation, what we sometimes see if you have any reducing agents in a bus. So this bus is really stable. You won't see any gold seedings or precipitations in the filter, for example, or at the heaters. And it can be really processed over the full bus life without, let's say, in between maintenance.
Okay, thank you. So the next question is Aurotech G-Bond 2 really corrosion free?
It's a mixed reaction gold. So that is what I explained. So we have a initial immersion reaction, but as soon as the gold seedings are plated, they will act as the catalyst to work, or that the reducing agents can work. We still have some portion of immersion reaction because it still works with the ENIG process. So, but let's say the immersion reaction is so far reduced that it really cannot be detected in the cross section anymore. And so that's the point where you really have to highlight in the reaction mechanism. There is still some sort of immersion but it's so far reduced that you cannot see it in the investigation anymore.
Okay, thank you. What are the factors that can trigger corrosion?
Yeah, that's a point. It's not only the gold bars, and this is something you should always consider if you look into corrosion. Of course, the gold bars plays a big role, and with improving the gold bars, you can further improve corrosion, but you also have other factors which get into play. So it's the roughness of the substrate that you provide. If you have a higher roughness, you have a higher risk for formation of corrosion than if you have a very smooth copper. If the bases are, let's say, operated out of spec, the nickel or the gold bases, or if you have any components leaching from the solder resist or from the base material, this can also, let's say, interact with the nickel plating already. And if you have any disturbed nickel plating, these are also typically the areas where the corrosion can attack. And so to really run the process properly, you have to have all the whole process step under control. And so that's, let's say, the whole package has to be controlled, and the gold bars itself is just one part of it.
Okay, thank you. So the next question is, will the Aurotech G-Bond 2 be able to fulfill the future demands of the IPC 4552?
Yes, it will. Let's say, at least from what we know about the expected future demands of the IPC 4552, they will be all fulfilled, yes.
Okay. So the cold control range is stated with 0.3, between 0.3 and 0.7 gold. So can bus be really operated at the 0.3 level?
Yes, in principle, yes, it can be operated, and it will work in this range properly without any drawbacks or any limitations. But of course, you lower you go with the gold content, the more difficult it is to really keep the gold content, because then you have to replenish more frequently the gold that you played out. And here, so then you really need a very close control of the gold replenishment itself, and how much is reduced. But it's possible to operate with a 0.3 gram per liter. Yes.
Okay. And related to this topic question, what failure is expected if it drops below 0.3?
So what I have to say is that so far we haven't observed any failure, even if we go with a very low gold content. What we would expect is that you see maybe some that the thickness distribution gets worse, or you may even see some skip plating on the panels, but so far we haven't observed this.
Okay, understand. So wetting angles for ENEPIG seems to be better after reflow. Is this really true?
Yes. Yeah, it's right. I mean, it looks surprising if you look into this, but this is something that we also have observed before. And to be honest, it's not really 100% clear why this happens, but we assume that it's maybe due to some combustion of organic contaminants, or which might be there in the reflow process. And but this is, let's say, something which is not unusual, and what we have seen also with other finishes before, that with ENIG, after reflowing, the soldering appears better.
Okay, thank you. Are really all level in working window on the zero?
No. In the working window DOE, no. That was what I mentioned. In fact, there are 3 locations out of the 770 which showed one single small corrosion event. But as I said, this was a working window to really evaluate the final process window for the bars, where some of the settings were really far out of the control, and where really they were just 50 or 150% of the target value. So then finally, when we adjust the really operating window in the technical data sheet, this will be considered, and so that we can be sure if the bus is operated in this operating window, then we can be sure that we have the 100% corrosion free.
Okay. What frequency and level of analysis is needed to operate the bus?
So actually, most of the components are replenished only by drag out, and there are few analyses which have to be done. Currently, we operate them once per day. Possibly will be only weekly later on when it's adjusted, and it's kind of as we offer this replenishment system, this dosing system. There is really no big fluctuations expected, and so the process can be operated very constantly, or very constant. Yeah.
Okay, thank you. Is special equipment necessary to control the gold bass? And please explain a function of the equipment. Can we operate the G-Bond tool without auto-dosing system?
Yes, possibly yes. But what I have to say is that the replenishment has to be done in a certain frequency. So you have to replenish like hourly or half hourly. And so this is why we introduced the automated dosing system, which is actually nothing which is super expensive or so. It's a really simple dosing unit with some pumps and the control unit. And you can, of course, you can operate the bath without the system, but it's not recommended because it's some extra work and it bears the risk of failures when you skip some of the replenishment steps. And so therefore it's definitely easier to run with the automated system.
Okay, thank you. Do we need to dummy plating before mass production for activated the BESS?
No, that's not necessary. You can just start right away. There is no dummy plating necessary.
Okay. Can we apply G-Bond 2 with C and N?
Yes. That's what I also mentioned. It's applicable for our CNN, for our Aurotech NIC, for SIT plus, so for all kind of mid-phosphorus nickel bases, and as well for the ENIPIG processes as well. No matter if pure palladium or palladium phosphorus.
Okay. Is there any corrosion type you consider to be most critical?
Definitely yes, and this is a surface corrosion, and this is also why we put so much effort in the detection of surface corrosion, like I described with the protection layers. Surface corrosion is therefore so critical because it spreads over large areas, and with that can really cause problems or inhibit the formation of the IMC, and with that then can lead to solder issues, solder dewetting, or also bonding adhesion problems. So therefore, this is really this type of corrosion which we actually consider to be most critical because it's in area and it really is at the interface between the nickel and the gold, and with that disturbs any further assembly on top. So yes, this is the surface corrosion is the most critical, and this you should really take care that you don't create this.
Okay. Can you please describe the evaluation procedure for the corrosion in more detail?
Yes. So as I said, so typically we study 8 to 10 PTHs, and then for each PTH we check minimum 7 locations, which are the 4 locations at the corners or the entrance of the PTHs, and then 3 locations at the PTH ring. And then we judge, we count, really we take images and then we count the corrosion events on these images and see how deep the corrosion events go into the nickel layer. And then we sort like in different categories from 0 to 20%, from 20 to 40%, from 40 to 100%, and any surface corrosion in a separate category. And this, we create a table and just count the events. And then we look into, okay, how many events of a certain depth do we find for one location? And if we have less than 10 events, with all not deeper than 20%, or just one single event which is less than 40%, then this is a level 1, for example. If we have 10 or more events and 5 of them or more are deeper than 40%, then this is a level 3. Level 3 is also if we see surface corrosion, which is more of 30% of the overall image. And so everything which is not level 1 and level 3 and which is not perfect, this is a level 2. And from these different levels which have been created, we then count how many we collect all the levels which for the 7 images for one PTH, and then we form a kind of mean judgment for the one PTH and say, okay, if we have no corrosion, then it's a rating of 0. If more than 60% of all the locations that we checked have a level 0 or 1, then this is a rating of 1. And if more than 40% of the locations show a level 3, then this is a rating of 3. And a rating of 2 would be then everything else what is in between. And so this is how we judge and how we also do our development, and which also helps to determine tendencies in the gold bars development, to see, okay, which goes in the right or wrong direction. And but now with the G-Bond 2, it's really just 0.
Okay, thank you for a detailed answer. What is the magnification level to be considered while evaluating a nickel corrosion?
Not typically in the IPC, what is recommended is the 1000, and so and there in the IPC, it's also recommended to do the evaluation by light microscope. To be honest, we see also some limitations in there, and when we do our internal investigations, we always use a combination of both, of light microscope and also SEM, to really be sure, because in the cross-section preparation, you might also create some artifacts where it's difficult to see in a magnification of 1000 in the light microscope if this is corrosion or not, and then it helps to either go into higher magnification or to look into the with the SEM to really decide.
Okay, and the second question to this is nickel protection layer mandatory for a nickel corrosion analysis according to IPC?
According to IPC, it's not mandatory, no. But
so it's only recommended, yeah?
Yeah, right. It's and we also strongly recommend this because it helps you to detect, in particular, surface corrosion. To detect surface corrosion without a protection layer is really difficult, because then it's really difficult to distinguish between really corrosion or any artifacts created by the cross-section preparation. If you just have a small gap between the layer and the PCB and the resin, then easily the gold layer peels off and it's not necessarily corrosion. And with a light microscope, then you really have hardly a chance to detect this.
Okay. Can we get more detailed information about the process, and if yes, how?
Yes, of course. I mean, we are happy to give any further introduction to the customers. If you are interested in, just contact either me or our local contacts, and then we can arrange any dedicated meeting or introduction with the further details.
Okay, thank you. What are the main benefits and limitations compared to the second generation gold bars?
Compared to the second generation gold bars, the main benefit is definitely the improved corrosion. But I mean, these are, because of the different reaction types, they have to be considered also as differently. With the third generation gold bars, you have a higher portion of autocatalytic reaction. That means the bars needs a bit more of a maintenance. It needs to be a tight or more process control and monitoring. This is what I meant. You have a more frequent replenishment necessary to really ensure that the bars is stable. So I would say the operating of the second generation gold bars is easier, but definitely if you really look and looking for a corrosion-free ENIG process, then you have to move to the third generation gold bars.
Okay, thank you. And our last question for this Q&A session is following: is the corrosion investigation done by SEM or light microscope?
Let's say the quick one is done by light microscope, and then the details are checked by SEM. It's a kind of compromise you have to go here. With the light microscope is definitely the cheaper and the faster method that can be done easily, and where you can easily screen a whole cross section with several PTHs in short time. But yeah, your resolution is limited, and if you want to look in more details, then you really better add some additional SEM investigations.
Thank you a lot, Britta. So it's time to wrap up our webinar session. Thank you,
Welcome.
everyone. We really appreciate you being here. Soon you will receive the replay link for this webinar. If you like this session, feel free to share the link of the recording, which will be available to you after the receiver registers. For our upcoming and on-demand webinars, please visit atotech.com/media/webinars. We will also keep you updated about our webinar schedule via email. Stay healthy and safe, and see you next time. Thank you.